Recall that there are four tissue types in the body: epithelial, that covers open spaces; connective, which is like the kitchen drawer; muscular, which we have here; and nervous, which conducts electricity. What sets muscular tissue apart from the other tissues is its ability to contract. There are little tiny proteins in your muscle cells, and when they all work together properly, they can produce movement and tension. Muscle tissue has some other characteristics, such as excitability. This means that it is capable of receiving electricity, or what we call an action potential. The terms extensibility and elasticity both refer to action of whole muscles, like the entire muscle you see here, the biceps brachii. For example, the detrusor muscle that surrounds the bladder is able to extend and then relax as your bladder incrementally fills. The muscle has elasticity that allows it to expand, but also recoil to its original shape. Much like the other organ systems we've already looked at, muscular tissue has some functions that are intuitive, and then it has some functions that are a little bit unexpected. I'm sure that many of you have thought about your muscles' ability to produce movement, maintain your posture, but have you ever thought about how they support your squishy organs? Or how they guard entrances and exits? We're all familiar with shivering to produce heat, but muscles can also help store various forms of readily available energy. There are some strange and wonderful functions of the muscular system, such as the complex actions that cause pupil dilation or constriction, and the scattered little muscles all throughout your skin that pull your hairs upright when you get goosebumps, those muscles being called erector pili. There are three types of muscular tissue. There's smooth muscle, cardiac, and skeletal. That's it. I've listed these three cells here because they are a spindle-shaped smooth muscle fiber on the top, a branch cylinder shaped cardiac muscle in the center, and a straight up cylindrical shaped skeletal muscle cell. For the rest of this chapter, we're going to focus on skeletal muscle and just use it as an example to learn about muscular contractions. And I have to stop calling them muscle cells. We call them muscle fibers. This is because one of these muscle fibers, you could say like it's born from the fusing of many precursor cells. Muscle fibers all have specialized cell membranes that we call the sarcolemma. Sarco is a prefix commonly used for muscle, along with myo and meso. The sarcoplasmic reticulum sounds like it's a completely made up word, but it's not. This is an endoplasmic reticulum, just like those we learned about in a previous chapter. But in muscle fibers, it's specialized to intake and release calcium cations. The sarcoplasm is just the cytoplasm, again, laden with calcium, and we just give it that special name, sarcoplasm. And finally, just as skin cells called melanocytes made the protein melanin, muscle fibers make these cylinder-shaped proteins called myofibrils. Unfortunately, the myofibril is cylinder-shaped just like an entire muscle fiber is cylinder-shaped. And this can lead to a lot of misunderstanding and frustration with diagrams. Always, always, always ask yourself if you are looking at a muscle fiber, which is pictured at left with multiple nuclei and striations, or if you're looking at a myofibril, which is pictured on the right with actin and myosin proteins visible, and the sarcoplasmic reticulum, that blue web-like structure, covering it. It's these myofibrils that fill up over 80% of the sarcoplasm of a muscle cell, pushing to the side the nuclei and the mitochondria.